All right, we're going to start with a quick video on, it's a review video actually for section 1.3. We're going to look at rationalizing denominators. Now, I'm hoping this is a topic you've seen before, or a skill that you've learned in the past, or at least you're familiar with, maybe from an algebra class. And in trigonometry, we're going to be doing this a lot. It's just kind of a standard way to simplify fractions that have square roots on the bottom. Okay, so that's really what we're working with. We got, just as an example, you might see something like 2 divided by square root of 3, or 2 over root 3. Okay. Now, when we work with fractions, generally speaking, we're going to want to do things with them, like find the least common denominators, or add the fractions together, or multiply the fractions. And in many of those operations, it's going to be a lot easier to work with a fraction where there's no root on the bottom. Okay, so if it's just a whole number on the bottom, it's going to be a lot easier to work with than a square root on the bottom. Okay, especially working with least common denominators. And so our goal is to get rid of that root. Well, there's only a couple ways to get rid of a root. To square it, or, well, I guess really squaring it's the only way, but there's different ways to square it. So you could raise it to the second power, or you could multiply by itself. Okay. And so what we're going to do is we're going to try to rewrite the fraction without changing its value. Well, how do you rewrite a fraction without changing its value? You multiply it by 1. Very common. Okay. So let's say I were to multiply this fraction by the number 1. Okay. Very large number 1. Hopefully that looks like a 1. Okay. And now anything times 1 is itself, so we haven't changed the value of that fraction. So let's just say we use a clever idea here, and we rewrite this 1 as a square root of 3 divided by a square root of 3. Remember that anything divided by itself is 1, so that has to be 1, right? Square root of 3 over square root of 3. And anything times 1 is itself. It hasn't changed value. Okay? So if we cleverly write the 1, or choose a very interesting way to write the 1, we can change what the fraction looks like without changing its value. Okay, and so then we just multiply across, right? Multiplication, multiply across. 2 times root 3 is equal to 2 root 3. That's on top. And root 3 times root 3 is the same as root 3 squared, right? You multiply it by itself, you square it. If you square a square root, they cancel out and you're just left with the 3. Okay, so I got 2 root 3 over 3. Right, and that's the simplified form, that's the rationalized form. Okay, so we've rationalized the denominator by essentially eliminating the root from the denominator. This fraction will be much easier to work with if we have to add and subtract fractions or find a least common denominator. Just one more quick example. We had the fraction 5 over, let's go with the square root of 10. Okay. 5 divided by square root of 10. Well, in this example, again, I'm going to rewrite this fraction without changing its value. So I'm going to use the number 1, multiply by 1. Rather than writing that in, I'm just going to use the denominator, okay? So we're going to multiply by the square root of 10, which is the denominator, over the square root of 10. Okay. So on the top, I get 5 times the square root of 10. And on the bottom, square root of 10 times square root of 10 is the square root of 10 squared. Square and the square root cancel out, so I just have 10. Now what's interesting, the reason I chose this example is because sometimes you can reduce these fractions after the fact. Anytime you have a common factor outside of the root, okay, so here's a 5 and a 10, both outside the root. If they have a common factor, you can reduce them. You cannot reduce a number in a root with a number out of a root. So you can either reduce two numbers out of the root or reduce two numbers in roots, if they're both in roots. But in this case, I've got 2 on the outside that I can simplify. So 5/10 is the same as 1/2. Okay, so I can reduce that down to a 1 and a 2. And then I could rewrite this in its most simplified form as the square root of 10 over 2. Okay? And so square root of 10 over 2, notice that again, I cannot reduce this because I have one number in the root, one number out of the root. They can't be reduced together. Okay? Alright, so essentially the main idea here is that we want to multiply by that root on the bottom to get rid of it, but if we do that to the bottom, we also have to do that to the top so that we're really multiplying by 1.